If you walk into an auto parts store or scroll online for a set of replacement spark plugs, you are immediately confronted with a massive price gap. You will see basic copper spark plugs sitting on the shelf for $2 or $3 each. Right next to them, single and double platinum plugs sit around $6 to $8. And at the top end, premium iridium plugs command $15 to $20 per plug. That raises a crucial question every vehicle owner asks. Does paying 4 or 5 times more for iridium spark plugs actually unlock extra horsepower? Or are you simply falling for clever automotive marketing? The short answer is no. Installing expensive iridium plugs in an engine designed for basic copper will not magically add 30 horsepower to your car. However, putting the wrong type of spark plug into a modern engine can trigger violent engine misfires, destroy your expensive ignition coils, tank your fuel economy, and cause severe damage to your catalytic converter. To understand why these metals matter, we first have to strip down how a spark plug actually operates inside your engine combustion chamber. A spark plug has one primary job: deliver high-voltage electrical energy from your ignition coil into the combustion chamber, jumping a precise air gap between the central electrode and the ground electrode. That electric arc ignites the compressed air-fuel mixture thousands of times every single minute. When electricity jumps across that tiny gap, it creates intense heat, temperatures exceeding 4,000 degrees Fahrenheit, alongside extreme chemical corrosion and physical erosion. Every time a spark fires, tiny microscopic fragments of metal are blasted off the surface of the electrodes. Over thousands of miles, that electrode material steadily wears down, making the spark plug gap wider and wider. As the gap widens, your ignition coil has to push higher and higher voltage to force the spark to jump the physical distance. If the gap becomes too wide, the ignition coil simply cannot supply enough voltage. The spark fails to jump, resulting in an engine misfire, unburnt raw fuel dumping into your exhaust system, and a flashing check engine light on your dashboard. This is where metallurgy comes in. The material used to tip the center and ground electrodes does not change the laws of physics, but it dramatically changes two critical variables: electrode diameter and melting point resistance. Let us start with the original baseline: copper spark plugs. When mechanics talk about a copper spark plug, they are using slightly misleading terminology. The core of almost every modern spark plug is made of solid copper, because copper is one of the absolute best thermal and electrical conductors on the planet. However, pure copper is extremely soft and has a relatively low melting point. If you exposed a pure copper tip directly to the intense heat inside a combustion chamber, it would melt into a blob within minutes. Therefore, a so-called copper spark plug actually features a solid copper core encased in an outer nickel alloy shell, with a center electrode made of solid nickel alloy. Because nickel alloy is a relatively soft metal compared to exotic precious metals, manufacturers have to make the central electrode relatively thick, typically around 2.5 millimeters in diameter, so it does not erode instantly under heat. What are the advantages of copper plugs? Because copper conducts heat exceptionally fast, copper plugs run cooler under extreme conditions. They deliver a very clean, low-resistance electrical pathway. However, the drawback of nickel alloy electrodes is terrible durability. Nickel erodes rapidly under intense electrical arcing. A standard set of copper spark plugs will only last between 20,000 and 30,000 miles before the gap erodes beyond safe limits. Who should use copper spark plugs? Copper plugs are ideal for older vehicles designed before the year 2000, lawn equipment, older carbureted engines, and specific high-boost, performance-modified turbocharged engines, where the owner changes spark plugs frequently after track days and needs maximum heat dissipation. If you put standard copper plugs into a modern vehicle designed for long service intervals, the plug gap will widen so quickly that your high-output ignition coils will overheat trying to bridge the gap, causing premature coil failure within a year of driving. This brings us to our second category, platinum spark plugs. To solve the rapid wear problem of nickel alloy, automotive engineers began welding tiny discs of platinum onto the tip of the center electrode. Platinum is a dense, highly stable precious metal with a melting point of over 3,200 degrees Fahrenheit, nearly 1,000 degrees higher than nickel. Because platinum resists heat erosion so effectively, engineers can make the central electrode smaller while extending the operational lifespan of the plug to 60,000 or 80,000 miles. Now, when shopping for platinum plugs, you will notice two distinct varieties, single platinum and double platinum. Understanding the difference between these two is critical for preventing engine damage. A single platinum spark plug features a platinum disc welded exclusively to the center electrode, while the ground electrode, the small curved arm above it, remains standard nickel alloy. Single platinum plugs work perfectly in traditional ignition systems where electric current flows in one single direction, from the center electrode jumping up to the ground electrode. However, many vehicles manufactured throughout the late 1990s and 2000s utilize what is known as a waste spark ignition system. In a waste spark system, one single ignition coil fires two spark plugs simultaneously on opposite cylinders. To complete the electrical circuit, current flows in the normal direction on one cylinder, from the center electrode to the ground electrode. But on the companion cylinder, the current flows in reverse, jumping from the ground electrode back into the center electrode. If you install single platinum spark plugs into a waste spark system, the cylinder operating in reverse will rapidly blast away the soft nickel alloy ground electrode, widening the gap in less than 15,000 miles. This is why double platinum spark plugs exist. A double platinum plug features a platinum pad welded to the center electrode and a matching platinum pad welded directly to the ground electrode. This ensures maximum erosion resistance regardless of which direction the high-voltage electrical current travels. If your car's owner's manual specifies double platinum, never downgrade to single platinum or copper, or your ignition system will suffer rapid electrode decay. Finally, let us analyze the absolute king of modern ignition technology, iridium spark plugs. Iridium is one of the rarest, densest, and most heat-resistant metals known to science. It has a staggering melting point of over 4,400 degrees Fahrenheit, nearly 1,200 degrees higher than platinum, and it is roughly 6 times harder and 8 times more resistant to chemical wear. Because iridium is so exceptionally tough, spark plug manufacturers can shrink the center electrode down to a needle-thin point, sometimes as fine as 0.4 millimeters in diameter. Why is a microscopic central electrode such a massive technical advantage? Think of electrical voltage like pressure pushing through a hose. If you spread electrical voltage over a wide, thick 2.5 millimeter electrode, the electrical energy scatters across the entire surface area, requiring higher overall voltage to force a spark gap jump. By concentrating that exact same electrical charge down to a needle-thin 0.4 millimeter iridium tip, you concentrate the localized electrical field. Voltage jumps across the gap with significantly less effort from the ignition coil. This needle-thin electrode design offers 3 major real-world benefits. First, superior cold weather starting and idle stability. Because the thin tip requires less voltage to create an arc, your car fires up instantly on freezing cold mornings when battery power is low. Second, complete elimination of spark quenching. When a spark ignites the air-fuel mixture, a tiny flame kernel begins to grow between the electrodes. Large, thick copper or nickel electrodes absorb and soak up heat away from that growing flame kernel, an effect called flame quenching. The razor-thin tip of an iridium plug allows the flame kernel to expand freely into the combustion chamber without losing heat energy, resulting in more complete combustion, sharper throttle response, and lower tailpipe emissions. Third, extreme longevity. A high-quality set of factory-installed iridium spark plugs can easily last 100,000 to 120,000 miles without the electrode gap expanding by even a fraction of a millimeter. For ultra-high-performance modern engines, especially modern direct-injected, turbocharged vehicles running high compression, manufacturers have even introduced ruthenium spark plugs, an alloy closely related to iridium that offers even higher resistance to extreme cylinder pressures. So, how do you decide which spark plug you should buy for your specific car? Follow this absolute golden rule of automotive maintenance. Always match or exceed the OEM factory specification. Open your vehicle owner's manual or check the emission label under your hood to see what metal technology your vehicle came with from the factory. If your car came from the factory with basic copper plugs, upgrading to platinum or iridium is completely safe and will drastically increase your service intervals without hurting anything. However, if your car came from the factory equipped with iridium or double platinum spark plugs, DOWNGRADING, to cheap copper plugs to save $20 is a huge mistake. Modern engine control modules are calibrated around the precise electrical resistance, heat range, and electrode gap stability of precious metals. Installing copper plugs in an iridium spec engine will quickly overload the coil plug modules, cause intermittent misfires under heavy acceleration, trigger knock sensors, and force your ECU to pull ignition timing, directly reducing your fuel efficiency and engine power. Here is a final critical warning regarding installation. First, never attempt to manually gap fine-wire iridium or platinum spark plugs using a cheap coin-style spark plug gapping tool. Slipping a hard metal coin tool against a microscopic 0.4 mm iridium tip can easily snap the delicate precious metal pad right off the center electrode, ruining a $15 plug instantly. Premium iridium plugs come pre-gapped from the factory inside protective cardboard sleeves. If you must verify the gap, use a delicate wire-style feeler gauge and exercise extreme caution. Second, always use a torque wrench when tightening spark plugs into aluminum cylinder heads. Over-tightening can stretch the threaded metal shell of the plug, altering the heat transfer path and potentially stripping the delicate aluminum threads inside your engine block, turning a 30-minute maintenance job into a $2,000 cylinder head repair. By understanding the clear metallurgical differences between copper, platinum, and iridium, you can choose the exact plug your engine needs, protect your ignition components from costly electrical damage, and keep your engine running smoothly for tens of thousands of miles. If this straight-to-the-point technical breakdown gave you value, hit the like button, drop a comment with the year, make, and model of your vehicle, and subscribe for more technical automotive guides. Thanks for listening.